In this video, we explore the various modes of connection, wired and wireless, and discuss the advantages and disadvantages of each. There exists a huge range of modes by which you can connect devices together. At GCSE level, you need to be aware of Ethernet, a method of wired connections, alongside wireless and Bluetooth, methods of wireless connection. Ethernet is a standard for networking technologies used for communication on wired local area networks. It includes a number of associated protocols which are rules for governing communication. It provides a reliable, error-free communication between 2 points on a network. Data is transmitted in frames, which includes a preamble of bits used to synchronize the transmission and receiver clocks, a start frame delimiter to signify the start of important data, the source and destination address for the network interface card, known as a MAC address, the actual data, which could include other protocol information too. So if you were communicating on a wide area network, you would need IP addressing, and this would be part of the data. Part of the frame also contains a cyclic redundancy check, which is used for error checking on the frame to ensure that the destination computer knows whether transmission was successful or not. Ethernet is a standard that's been around for many years, and it's evolved as networking topologies have also evolved. Here we can see a bus network. A shared backbone cable means a protocol such as CSMA/CD or carrier sense multiple access collision detection is needed to listen for communications before transmitting and detecting when two computers transmit at the same time. This is necessary because there's only one cable between all the computers. Here we can also see the cable that connects these computers together and the BNC connectors on the end of those cables. Bus networks are not really part of the GCSE specification, but it's helpful when understanding Ethernet just to understand the history of this protocol. What you do need to be aware of is star networks, and here Ethernet is the chosen standard for implementing a star network. With twisted pair cables, duplex communication is possible. That means sending and receiving data at the same time because different wires are used for transmit and receive. Therefore, the CSMA/CD protocol is not needed because frames can't collide. With mesh network topologies, you can still use the Ethernet standard, but additional protocols for routing between the switches are also going to be needed. Let's have a quick recap of Ethernet before we move on. It's a standard for networking technologies. It's used for communicating on a wired local area network. Includes a number of associated protocols, rules for governing communications. It provides reliable, error-free, fast communication between 2 points. It was originally used in old-style bus networks, but is still used today in more modern star and mesh networks. Data is transmitted in frames, which include a preamble of bits used to synchronize transmission, a start frame delimiter to signify the start of the data part of the frame, a source and destination MAC address, the actual data, and error checking information. User's location is limited by the need for a physical cable connection, and a setup relying on Ethernet also relies on lots of cables, connections, ports, and physical hardware, which will of course affect the overall cost of the network. Wi-Fi is a common standard for wireless networks. The main advantages of Wi-Fi networks over a wired one is that users can move around freely within the area of the network with their laptops, handheld devices and phones to get an internet connection. Users are also able to share files and other resources with other devices that are connected without having to be cabled into a port. Not having to lay lots of cables and put them through walls can be considerably advantageous in terms of time and expense. It also makes it easier to add extra devices to the network as no new cabling is needed. If you're a business, say a cafe, having a wireless network that's accessible to customers can bring you extra business. Customers generally love wireless networks because they're convenient. Wireless networks can also sometimes handle larger amounts of users because they're not limited by a specific number of connection ports. Instant transfer of information to social media is made much easier. For instance, taking a photograph and uploading it to a common social networking site can generally be done much quicker with wireless technology. Like most things in computer science, there are always trade-offs, and what you'll find with wireless networks are the speeds tend to be slower than wired networks. It has to rely heavily on signal strength to the wireless access point. Signals can become too obstructed. It's also considered much less secure than a typical wired network. Bluetooth is another, more modern and increasingly popular method of connecting devices wirelessly. It has a very short range compared to Wi-Fi, but it also consumes a lot less power. This makes it ideal for connecting personal devices, as shown here. So let's just recap this part. Wi-Fi is a common standard for wireless networks. Users can move more freely around, it's easier to set up and less expensive, it's convenient to use, can handle a large number of users. The transfer of information to social media is much easier. However, the speeds tend to be slower than wired networks. It does rely on signal strength to the wireless access point, and these signals can be easily obstructed, and it is generally considered less secure. Bluetooth is another more modern standard for wireless networking. It's ideal for connecting personal devices. It has a very short range, typically around 10 meters, but it has a very low power consumption when compared to Wi-Fi. The rest of this video goes a little beyond the GCSE specification, so there's no need to take any more notes. It's well worth watching, however, as it helps to add an extra level of understanding behind how Ethernet and Wi-Fi actually work, and it's excellent preparation for A-level. So in terms of Ethernet that we spoke about earlier, let's have a look at what happens to data being transmitted from computer A to computer B on a wired partial mesh local area network. The first thing that's going to happen is the data is going to have its header and CRC applied. Now, for the purpose of this illustration, the header includes the preamble, the start frame delimiter, the source and the destination MAC address. Before the computer goes ahead and transmits this frame, it's going to check whether there's another communication on the cable that it's attached to. Now, if we're using twisted pair, this isn't strictly necessary, but we're going to go ahead and do this anyway. So seeing that there's no communication on the line, the frame is then transmitted to the switch. The first thing that happens here is we examine the CRC and check that the frame arrived intact, and if not, we'd have to request for it to be retransmitted. Let's assume that the CRC check is successful. The switch is then going to examine the destination address in the header and make a decision about which port it should send the frame down. Before transmitting, the switch is going to check there's no communication on the cable, and then it's going to send the frame down. And seeing that there isn't, it can transmit the frame to the next switch. The switch is going to have a look at the CRC, check that it's been transmitted correctly, and then examine the destination MAC address in the frame. Realising that it's for computer B, it can then send the frame down the cable, of course checking there's no transmission on the line already. The frame is then sent to computer B, where it can be unpackaged. After the CRC check has been performed, the header and the CRC is stripped away, and the computer is left with the data. You'll notice that this network is significantly more secure because the data only travelled between the switches that it needed to, and the other computers on the network were completely unaware of the transmission. This is how the Ethernet protocol works. Now let's take a look at how wireless works in a little more detail. Because wireless is using electromagnetic radiation to transfer signals between 2 points, they have to be transferred on a number of frequencies, and each frequency is given a channel number for convenience. So for example, BBC Radio 1 is at 97 MHz, BBC Radio 2 is 88 MHz. We can think of radio channels as being on a frequency and at the same time being on a channel. The same is true for Wi-Fi networks. Different countries can operate different frequency bands, and here we have a typical illustration where we've got 2.437 GHz being channel 6 on a Wi-Fi network. This means that if your network interface card on your computer is set to channel 6 and your router is also set to channel 6, then the two devices can communicate with each other on channel 6, and indeed with any other devices that are on your local area network, as long as they're also tuned to channel 6. It's completely up to you which channels you decide to use, but there are some implications for interference with adjacent channels. Each channel is actually 22 MHz, which means for channel 6 you get some bleed over to channel 5 and to channel 7, as we can see shown here. This is generally not considered a problem because you've got filters that will filter the frequency that the device is actually listening to. However, it would be a good idea to make sure that you're using a different channel to another local wireless network. So for example, here we might decide to use channel 3 if our neighbour is using channel 6. Here we can see the full range of channels and frequencies used by Wi-Fi. Now this is really too much detail for the exams, as we've said already. All you need to know is that Wi-Fi is operating on frequencies, and frequencies can belong to channels. As long as two devices are transmitting and receiving on the same frequency or channel, then they can exchange data with one another.